Okay, so here's lesson A-14, and this is on page 34. And so what we're going to do here is use continuity to find unknown constants. So we're going to do 3 examples, and here's this first one. Find the value of k that makes the function continuous. So if you have a problem like this, this is from page 33 that we wrote down. These are the 3 conditions of continuity. And this 3-step continuity test, if we can get the same number for all 3 of these, then these conditions up here are satisfied and the function is continuous. So what we'll do is let's set up the 3-step continuity test and then see if we can find an equation that will allow us to solve for k. Okay, so the 3-step continuity test. Okay, so first we want to look at g of 3. Okay, so we only have to check it at this endpoint, 3. And then 2. The limit as x approaches 3 from the left, g of x. And the limit as x approaches 3 from the right. Okay. So let me do a little number line if it helps. You don't have to. All right, so g of 3. So when I plug 3 in, they want me to use this top one. So that is 3 cubed plus k. 27 plus k. Okay. Now, the limit as x approaches 3 from the left, so approaching 3 from that side, I would also be using the top. Okay, so again, I would be getting 27 plus k. And then the limit as x approaches 3 from the right, if I'm approaching 3 from the right, I would be using this bottom one. So that's 3k minus 5. Okay. Then you look at these 3 expressions you have, and they all have to equal the same number. So 27 plus k, we have that twice. You don't have to use it twice. We could just set that equal to this. All right. So what this is telling us is that 27 plus k has to be equal to 3k minus 5. Negative 2k equals negative 32. K is, okay, so k equals 16. Yep. Okay. Now we're going to do the second one, and then we'll do one more. The last one is going to involve 2 variables. So number 2, find the value of k that makes the function continuous. So same idea. So g of x is this. Instead of using less than and greater than signs, they're just saying that they want us to plug in to this top part if x is not equal to 3. So for every other number other than 3, we'd be using this top part. And then for x equal to 3, we would be using this bottom part. Okay, so let me set up my 3 steps. So g of 3. Limit as x approaches 3 from the left. Limit as x approaches 3 from the right. Okay. Now, when I'm approaching 3 from the left and the right, I'm going to want to be using this top function. And this top function, I'm going to have to simplify it because I'm going to have to do like algebra on the inside because I'm not going to be able to plug 3 in because of the denominator. So actually, all right, so let me figure this out. So g of 3, so x is equal to 3, so I'm plugging in there. So that is 3k minus 1. Okay, now for the limits from the left and the right, I've got to factor this and try to simplify. So 2 times negative 15 is negative 30. So two numbers that multiply to make negative 30 but add to make negative 1. Negative 6 and 5. Okay. So I'm just doing some side work here. So 2x squared minus 6x plus 5x minus 15. So I could do x minus 3. Okay. All right, guys. So what we end up having is 2x plus 5, x minus 3 over x minus 3. So I could cancel those out over there. So the limit as x approaches 3 from the left is the limit as x approaches 3 from the left, and then I could just put 2x plus 5 in there. And then 3 goes in, 6 plus 5 is 11. Okay, and then approaching 3 from the right, we'd be doing the same thing as x approaches 3. Also 11. Okay, so we got these three things, and they all have to be equal. So that means that 3k minus 1 has to equal 11. So 3k minus 1 equals 11. K is 4. Okay. Now the last one. So find the values of a and b that make the function continuous. So this problem here has, we're going to have to...
Good morning,
Oh, sorry.
Today is day 1. We have some announcements for you. Both the student entrance and exit is now moved back to the main entrance.
All right, sorry about the announcements, guys.
And afternoon dismissal will continue at the auditorium entrance.
I'm just going to stop.
Homecoming court. You have a mandatory meeting today right after school in Mrs. Sternaka's room. The National Honor Society meeting scheduled for Tuesday has been moved to Thursday during Saber time. Make sure that all current members have joined the newest Google Classroom. Please see Mrs. Perkins with any questions. There will be a yearbook club meeting tomorrow in Mr. Z's room during Saber time. Please make an e-call pass. On Wednesday, we will have a full school vote for those running for student council. Results will be given on Thursday morning. There will be a meeting for anyone interested in getting involved with Saber Stage Productions this Thursday, September 26th, day 4, during Saber time in the auditorium. Check out the posters and join the Google Classroom. Brookside PTA is looking for about 20 volunteers to help run carnival-type games at their back-to-school bash on Friday, September 27th, from 5 p.m. to 7 p.m. If you think this is something you might be able to help out with, please sign up in the main office. Teachers, there is a school tool training today at 2:30 in the auditorium. Please bring your device and be prompt. Wishing a very happy birthday to Brian Matthews. And the word of the month from the guidance office is respect. You accept somebody for who they are, even when they're different from you, or you don't agree with them. Respect in your relationships builds feelings of trust, safety, and well-being. Have a magnificent Monday, Sabers.
Okay. All right, guys. So hopefully you're able to follow like what I was writing without speaking. But yeah. So I have to do the 3 conditions of, or the 3-step continuity test at 0 and 4. And so when I do it at 0, I end up getting these results. And now at 4, so h of 4, I'm going to be plugging this in for x. So that would be 8a minus 3b. Okay. And then approaching 4 from the left, I'd be plugging into this middle. So again, 8a minus 3b. And then for approaching 4 from the right, then I'm plugging into here. So that's b minus 4. Okay. So guys, if you've got 2 variables, you will need at least two equations to solve for those two variables. So we're going to get one equation over here with these conditions, and then we'll get a second equation over here with these conditions. Okay, so, and yeah, like I said before, if something is appearing twice, you're not going to use it twice. I'll just say A, so over here, A has to equal negative 3B. Okay, that's what we get from those steps there. And then over here, we get that 8A minus 3B is equal to B minus 4. Okay, so those have to be equal. Those have to be equal. Okay. Now, since you know over here that A is equal to negative 3B, you can, anywhere that you see an A in the other equation, you could plug negative 3B in. All right, so yeah, so that there is going to go in there, negative 3B. So negative 24B minus 3B minus 4, negative 27B. Negative 28B is negative 4. So B is equal to, B is equal to 1/7. Okay, so B is equal to 1/7. So A is equal to negative 3 times 1/7. All right, guys, so there's that.